So welcome, and thanks for attending my talk. So my name is Adolfo Gracia Veytia. I know that some of the materials listed me as engineer at Chaingard, but as of last week, I switched jobs, and I am now with a company called StackLock. And it's a company, supply chain security company, that makes you choose better dependencies when you're building software. I also work with a number of open source projects. I am one of the technical leads with Kubernetes, SIG release. We are the folks that bring you Kubernetes every month. I also work on OpenVEX, on another project called Protobomb. I am on the Knative steering committee for the year. And I also collaborate on SPDX when I can. I'm also a cycler. But well, enough about me. So this talk, we're going to be talking about airplanes. And when I talk about airplanes, I want you to figure them as an allegory for your software systems because they're complex and they have lots of organization and people working behind them. So if you have been following the news, you may be familiar with this horrific experience that just happened where some passengers in Alaska Airlines plane started to hear some rattling, and off goes a section of the airplane wall like that. And it was, as the headline said, it was really a terrifying experience. Imagine being the person sitting there on seat 26F. When you saw this, there's like a failure with the airplane, right? And so the first question, if you think about that software, that airplane as a software system, would be, is this the case for a new airplane bill of materials? And of course, the answer is no, not at this time at least. And let me tell you why. Well, the first reason is probably not, because I'm sure some smart ass went and registered in the domain already. But the real reason is that at this point in time, you're missing some parts to make bill of materials a truly useful tool for remediating this. So the first one is, supposing the airplane failure was caused by a component, and it became evident of which component it was, and that airplane had a complete bill of materials of all of its parts, you would not only make Alan here very happy, but they also would be that you could go straight and swap that component for a better one. But unfortunately, when that disaster hit, you don't have the information required to know that, because you need to have a previous assessment on what happened. So how did organizations react? Well, they shut down everything. So they grounded all of the planes, and imagine the cost of having those planes in the ground. And why did they do this? Well, because it's you need time to do the assessment. And when you think about who has the answers to tell you if those planes are fit to fly, you need to consider that airplanes are really, really complex projects, really, really complex machines. So, 737 like those, I read that they had around 600 or 700,000 parts. Only the engine, experts assured me, has about as many dependencies as your usual node project. So, and then imagine doing that at fleet scale. So it becomes a real problem trying to surface that information, because you need to have the voices of the true experts who are handling the assessment surface so that you can ensure people if it's safe to fly or not. So after that, the FAA starts looking into that, and they also have to act to come in. The information is still limited, so they have to act with broad strokes. So they order a bunch of other planes to be grounded for a while. And at this point, you can see that someone deep in the dependency tree of the airplane knows what's going on, but the information needs to flow out. And I'm not going to do assessments on this case alone, but when you have a vulnerability in software, you need to have the voices of those who know the context surface. And this is why I titled this talk Maintainer Superpowers for Maintainers, because I want to give you like an insight of how sometimes that context gets lost. So this is the story of CVE 2023 3676. And this is Kubernetes CVE that surfaced. It was very sad because it was found, or the disclosure was being prepared right when we were trying to cut Kubernetes 128, and the patches were being worked on as we were cutting the release. So Kubernetes 128 was born with that vulnerability. So we had to release it because the patches weren't there in time. But well, you love all your children even when they're ugly. So, well, this is the first assessment, and this is the CVE record in the National Vulnerability Database. Probably it's too small, but you can see that the score is an 8.8. Now, this vulnerability has one particular thing. It only affects the kubelet, which is the part of Kubernetes that runs on the nodes of the cluster, and it only affects Windows nodes. So you can see here, this is the patch to remediate it, so that it's cleaning the information that goes into a PowerShell invocation. So if I scan, what happens if I scan the kubectl image of Kubernetes 128? That yellow square there, that's the GitHub identifier for the same vulnerability, but gripe, which I'm using there, is finding that vulnerability when I scan it. So this is pulling the Mac version of the image, and it's kubectl, so it's the wrong component and the wrong architecture when I do it, so it's a false positive. So why does this happen? Well, it happens because scanners are currently are really just database lookups. So right now I'm choosing these two because they're the scanners that are compatible currently with OpenVEX. So let me give you an example using gripe. So why did we get that false positive? So when you take gripe, gripe takes a software component, in this case the container image, and what it'll do is that it'll shoot through its big eye there a software decomposition ray into that, and so it will go pew, 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 until it breaks it apart into its components. And then these are the components that you see there listed. So by the way, this is something that we want to change because we want to go from breaking apart, cracking open the software, to scanning a better pattern would be to scan a trusted SBOM. Once you have that, gripe will take a database, and it'll start going through each of the components, asking, is this vulnerable? No. Is it vulnerable? No. Is it vulnerable? Yes. And then gripe will say, OK, then you are affected. But the truth is that, as I just showed you, there's no way that that CV could be in the kubectl image. And so with all the context I just gave you, you have to wonder, why did it do that? And well, this is because it's lacking that insight that I just gave you. And it's the way scanners are organized, they have like a lot of challenges. Because if you have like a new ecosystem, you have to work with them to get it recognized. So of course, it lacks the other assessment types that you can incorporate into the assessment. So back to the airplanes. After the investigation is still going on that thing with the door, which is not the door, it turns out that the faulty piece was what's called a door plug, which is what you put in the hole when you don't have a door. In the case of the 737s, they're manufactured by Spirit AeroSystems, that company there. But while this mess is going on, the airlines start looking at their airplanes, right? So they're starting wondering, well, if I'm not getting assurances from them, I'm going to go and check my airplanes. So in this case, Alaska found some issues. United Airlines checked their planes and said, oh, OK, they're fit to fly. But then, at the same time, Boeing goes and finds like another new problem with the same manufacturer that affects the thing. And not only that, the supply chain of that company apparently is not that transparent. So can someone tell me if I can fly or not? So in the end, what you really want to know is, does this flow affect the airplane that I'm about to take? And there are many people who can talk about that, right? So if you start thinking about the companies involved, Boeing is interested in like conducting a research because they have to care about brand and reputation, stock value. Then there's the government who tries to care for the public and safety at scale for everybody flying. Then there's the supplier who may have like a really good context on what's going on. And finally, the airlines, right? So if you are a person who's about to take an airplane, which of these companies would you trust to give you the context? I mean, Boeing at some point told us it was safe, then another thing surfaced. So do you trust the supplier of the door plug or the government, the airlines? Or what about doing an assessment of everybody together? And in software, we have the chance to do the same. So if you take software artifact, in this case, the container image, there are many sources of information that can give you some assessment of a vulnerability in it. So the first one is the ecosystems that we just talked about. So you can have information of vulnerabilities in the ecosystem for the programming languages used in the application, like Go, Python, or the operating system, in this case, Debian, for example. Then you can perform runtime analysis on the software. So there are companies already doing this. This is Cubescape or HBit. Those two are looking at when you run software, they will look and try to understand what part of the code is being called, what is not, and then give you an assessment. Then there's the software researchers. So some independent researcher can go and check a vulnerability to see if it's affecting a product or not. Then there's the application security teams in your company. So they may have strict policies that you need to enable, that you need to respect whenever you try to run a new workload. And finally, there's the maintainers of the project. So the problem right now with scanners is that we're stuck with the first, only with the first piece of the first part of the information. So when you run a computer scan, it would be awesome if you could get information from any of those. And this is where VEX comes in. So what is VEX? VEX is the Vulnerability Exploitability Exchange, and it's a system that communicates the impact that a vulnerability has on a given piece of software. It is a community effort run by CSAM. We meet on Mondays if anybody wants to join. And there are currently 4 VEX flavors: CSAF, CycloneDX, SPDX, and OpenVEX. So how does VEX work? In VEX, you have one document that has some metadata on top. But the key about the VEX documents are the statements. So statements are issued every time the knowledge of the impact changes. Or if you want to reassure what you know, it's also fine. But the idea is every time you know how a vulnerability affects your software, you should issue a new statement. So the statement is like pairs together your software, a vulnerability, and then a status, which can be it's affected, and VEX will tell you if it's affected, what you can do next. All of this capturing information from those trusted sources. Then it can tell you that you're not affected or that the project is looking at it. And so what is OpenVEX? So we just saw the overall VEX idea, and then below that, or forming that idea of VEX, we have the implementations, and OpenVEX is one of them. So OpenVEX is a project, one of the projects incubating in the OpenSSF. And OpenVEX is a specification, but we don't think of ourselves as a specifications project. We think of ourselves as a software project. And our mission is really to make it easy for open source projects to start generating that information so that scanners can pick it up and they can give us better results. So doing that, we have actual code that works. So we have a Go library. There are independent implementations already in Rust, in C# and in Java. And we have a set of tools that help you create those documents, handle them, mix them, We also recently implemented auto-discovery of documents. So if you have a container image, it will fetch it from you. We're working on finding VEX documents in GitHub repositories. And we also handle natively the signing of those documents by wrapping them in eToro attestations and signing them with Sigstore. We also maintain a bunch of documentation like autos. We have a guide for scanner implementers that we built together by capturing the feedback from Trevi and from the Trevi and the Gripe maintainers. And we're also building a couple of case studies. And I can say, well, and I just added this slide because I think I can now say that OpenVEX is also now a growing ecosystem. We started working because if you have a standard and there's no tools or there's no consumers, then you have a broken ecosystem. But we've been trying to work from both ends to try to get the generation and the consumption. So it's I think we now have an ecosystem bootstrap which is already going. And finally. Let me do the math. Yeah, I think I have time. So finally, the last thing I wanted to show you was a quick demo on how to, just hold on, how the tooling works. One sec. Okay, this is it. Is the font big enough? I can make it bigger. Okay. So this demo is going to be about the same vulnerability that I showed you earlier. So if I scan the kubectl image that I just showed you, hopefully it'll, okay, here it is. So we got the results that I showed in the slide. So that vulnerability is this one here. So it went out in Kubernetes 128, and then it was fixed in Kubernetes 128.1. And again, this is the GitHub identifier for the CV. So how could I vex that vulnerability? Well, to create the vex to handle that one, I would create a document like this one. So this is VexCTL, which is the main tool that OpenVEX provides to handle the documents. So you can see some of the data points that are going to go into the VEX statement. So first, the author, who's making this statement. The second is a product. In this case, I chose to use a package URL to determine the image that I'm gonna the vexing, so it's the kube control and then the digest for that image. As you know, please don't rely on tags because they can change. Then there's the vulnerability. I'm using the identifier that Gripe found on the scan. I could also add other aliases of the identifier for the vulnerability. Then the next one is the status. VEX provides the following statuses that I just showed you when I was going through the statement. So the status could be not affected, affected, fixed, or under investigation. So in this case, I chose not affected because that vulnerability does not affect my kubectl image. Then we have. So whenever you generate a VEX document, you need to provide a justification or an impact statement. The justification is a machine-readable label that tells you why it is not affected. And you can also provide an impact statement, like a human-readable statement to provide. And VEX consumers could choose to use that information and surface it to users. So I have that file already here. And the way you use it is really simple. So you run the same scan again, but in this case, this is for Gripe, but Trevi can also consume the OpenVEX documents. And then I pass the document. And then if I run it, well, yeah, that's it. So grep is going to do the scan, check out, and then the vulnerability is gone from the results. But if I remove this queue here, okay, so if you see here the results, you'll see that there's one ignored. So show suppressed. So let me pass the show suppressed so that grep can tell me what's missing. So you can see here the vulnerability, and it was suppressed by those VEX documents. So in this case, this is a simple case because it's a non-signed document. It's a document that I'm feeding straight to the scanner, but we also support having those documents signed and attached in the registry. So, well, it's the PR is almost there, but the feature is already complete. So the idea is whenever you have a container image, you can publish those VEX attestations together with it, and then it'll go and pick them up and have them ready for you. So that's how it works. So let me switch back to the presentation. It's not that one. Okay. And yeah, and so OpenVEX is an open source project. We run meetings every other Monday, and we have a channel in the OpenSSF Slack. Anybody is free to join. Something that I forgot to mention is that we're working on bootstrapping OpenVEX in lots of open source projects. So we recently ran a security slam together with the CNCF, where we dropped and initialized the VEX feeds for like 10, 12 projects, and they already started publishing VEX information. And right now we're also undergoing in Kubernetes a new effort to redo the security feed. This is together with SIG Security. So we're going to be changing the way we disclose the CVs in Kubernetes from the moment they get, the product security committee gets a notification about a new CV, all the way down to how we publish it, how we add it to the release notes. And we want to start publishing this information as well. I think that one is going to be like the best case to show this in an end-to-end use case. And yeah, so if you're interested in either the working on the standard or working on the specification or working on the tooling or working in any of those open source projects who are starting to generate their VEX information, please look for me. This is my avatar. If you see it, it's me. I'm on most of the open source Linux Foundation related Slacks. And yeah, well, I guess, well, that's all I had. And I think we have like 5 minutes for questions. Or
I have a question more in terms of the like the practical integration of VEX into the development workflow. Have you thought at all about how maybe it could be automation? There could be automation that would pick up like messages and commit logs. For instance, like as a developer, if I'm going to suppress, if I want to suppress a vulnerability that's coming into my issue log, I want to like find an easy route to being able to do that. So maybe like when I commit, I'm going to say something like, oh, this resolves CVE number, blah, 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 blah. This is the reason why. And of course, like if that's to be picked up, I suppose it would need some structuring. But have you thought about anything like that? Or like maybe if it could be in the source code itself in line, there's like an annotation or a comment. Is that something that the community's thought about at all? Yeah,
exactly. I mean, we honestly haven't thought about that. It's a great idea. So because that's our goal. We want to make it super easy for maintainers to generate this kind of information. So right now we're looking at how to reuse. So we have like a flow already. I was trying to document it for this one, but I didn't have time. We have a flow where you start with a golden sample of CVs that you want to start addressing, and then we reuse them every time you generate a new one. But that one could be like a really good addition, yeah, for VexCTL. So,
Thank you.
If you want to show up and propose it, or otherwise I'm going to steal it.
I might well do. All right, awesome. Thank you.
Hi, cool. So I just had a quick question. Where people are doing suppressions, is there anything that Vex provides for them to like provide detailed justification? So if they say, I've got this library that's part of my package, but no, it's fine, it doesn't affect me. Like, where they actually provide some like code, like a test case to prove that? Because there might be a risk that people would say, oh no, it doesn't affect me, but in reality, they might be wrong.
So the example I had showed was the simplest one, and it was like, if you find this vulnerability in this container image, whatever, it's not going to affect you. But we provide resolution for at the component level. So you can say, if you find this vulnerability in this container image in this or that package in versions, we could go that deeper. Some people have expressed interest in starting to think about how to express at the function level, but well, it's probably for the future.
I had one other quick question. You mentioned there were 4 different formats for Vex. Are they interoperable, or are there any challenges if people have got different ones?
I actually have a slide about that, or I've spoken about that in a previous conference. So here's to give you a quick rundown on interoperability. OpenVEX is compatible with, so the idea would be if you can go to the general definition of VEX back and forth, you're compatible, right? So OpenVEX can go there back and forth. The new SPDX VEX is going to be able to go back and forth. With CSAF, you can go from the general representation, from CSAF to the general representation. Yeah, I think. So it's one way or the other. It's almost fully compatible. And with CycloneDX, there's a number of incompatibilities because after like 2 years of discussing, when they released, they added new fields which kind of, I don't know, broke the current effort. So we need to bring those back into the community and see if we can get them adopted in others. But that's the status of it. Any other? All right. If not, then that's it. Thank you so much.